Hi guys. So a few people asked me how to do question 3, and so I thought that would be a good idea for me to do a video like this to show you how to do the question. All right. And for question 3 here, there are a few examples that I've done for the question for you, but I will go through how they get the answer. Okay. So step number 1 here, you need to work out the electron configuration for the atom. Okay, and you can look back at the lesson electron arrangement for how to do this. Okay, now without going back to that lesson, I'll tell you what to do here. So first of all, okay, you need to have a look at the periodic table. And the reason why we want to have a look at the periodic table is because we want to know what is the atomic number, right? Atomic number. So this is the smaller number, and the smaller number at the top of the box. Okay, and what this number tells us is the number of protons. Okay, and also it tells us the number of electrons for a neutral atom. Okay, so an atom without any charge. So this would tell us how many electrons there are. So for sodium here, the atomic number is 11. That means that there are 11 electrons. Okay, 11 electrons for sodium, and the electron configuration tells us how these 11 electrons are arranged. Okay, so remember that the first shell, the first electron shell can hold 2. The second can hold 8. So 2 and 8, that adds up to 10. And so we have one more in the third shell to make up 11 electrons. Okay. Now for oxygen, again, we do the same thing. We look at the atomic number, which is 8, and that tells us that, hey, there are 8 electrons. Okay. And these 8 electrons are arranged in the first shell, there's 2 electrons, and then the second shell, there are 6 electrons, okay, which makes up 8 electrons. Now, step number 2 here is we need to identify the number of valence electrons. And valence electron, remember guys, is the electrons on the outermost shell. Okay. So what that means is that this is the last number of the electron configuration. So sodium has 1 valence electron, and oxygen would have 6 valence electrons. Okay. Now, the next step is to decide whether the atom would lose or gain electrons. So, because sodium only has 1 valence electron, it would be much easier to lose that one. Okay. And so the next shell becomes the outer shell, and that's got 8. Okay. For oxygen, right, it would be much easier for oxygen to gain 2, so that the outer shell becomes 8 electrons. Okay. The next step is we need to write the electron configuration for the new amount. Okay. So because sodium has lost 1 electron, we only have 2 electrons in the first shell and 8 in the second. For oxygen, because it's gaining 2 electrons, the first shell still have 2 electrons, and the second shell would have 8 electrons now. Okay, so 6 plus 2, That's going to give you 8. Now, step 5 is to work out the charge. Remember that when an atom gains electrons, it would have more negative electrons than positive protons. Okay, so the ion is negative. Okay, so in this case, it's the oxygen that's going to be negative, and because it's gaining 2, it's going to be negative 2. When an atom loses electrons, it would have less negative electrons than positive protons. Okay, so the ion is going to become positive, and because sodium is losing just 1, it's going to have a charge of +1. Okay. Now step 6, the name and the formula. So if you have a positive ion, the name will not change. Okay. But if you have a negative ion, then the name would change to end with IDE or I. Okay. So in this case here, the oxygen has changed to oxide. All right. And the formula, remember, for the formula, what you want to do is you want to write the symbol, and then you want to write the charge at the top here. Okay. So the symbol for sodium is Na, and the charge is +1. Now this is kind of like in math. Okay. If you remember math, we don't write the number 1. Okay. So we just write the plus sign here. And for oxygen, symbol is O, and for the charge, it's -2. Now, basically what happened here is we just flip the charge around, okay? So it's just like, instead of writing -2, we write 2 negative. And the reason for this is to say that there are 2 more electrons, okay? There are 2 more electrons than there are protons. For the sodium, the 1+ here, that tells us that there is 1 more proton than electrons. Okay, so that's what it means. And then the last step here is to identify whether the ion is an anion or a cation. Okay, and remember that negative ions are anions and positive ions are cations. Okay, and remember we make that joke that cations are positive, right? Cats, they have paws. Okay. Now, I'm going to do another example here, actually 2 examples, so that you get a better understanding. Okay. So first of all, magnesium. So remember, first step, look at the atomic number. That's 12. That means you have 12 electrons. So how do we arrange these 12 electrons? Well, 2 in the first, 8 in the second, and that means we have 2 plus 8 is 10, so we need 2 more in the third, 2 more electrons. Okay? How many electrons will it gain or lose? Well, because it has 2 valence electrons, okay, it would be much easier to lose these 2 than to gain 6 more, right? If it loses 2, then the next shell already has 8 electrons there, in comparison to gaining 6 to make the third shell have 8. Okay, it's much easier to lose 2 than to gain 6. So that means that the electron configuration now will become 2, 8. And because we're losing 2, remember losing, that's going to give us a positive charge. And we're losing 2, so the charge is going to be +2. Because this is positive, this is a positive ion, we don't change the name. So it's going to be magnesium. It's going to stay as magnesium. And the formula is the symbol with the charge. And we just flip the charge around here. So instead of writing +2, we write 2+ to say there are 2 more positives. Okay? And because this is positive, this is a cation. Now for nitrogen here, right? Periodic table, atomic number for nitrogen is 7, so 7 electrons. All right. How are these 7 electrons arranged? We have 2 in the first, and then 5 in the second. All right. Now, because it has 5 valence electrons, it will be much easier to gain 3 than to lose 5. Right? We want to have 8 overall. It's easier to gain 3 than to lose 5. So this will become 2, 8. Right? 5 plus 3 is 8. So because we're gaining, this is going to become a negative ion. And because we're gaining 3, it's negative 3. Because this is a negative ion, we need to change the name. So it's going to end with I. Okay, so this becomes nitride. Okay, and the symbol is for nitrogen is N, and the charge, we flip the charge around, so this is going to be 3 minus instead of minus 3. This means 3 more electrons. Okay, and because it's negative, it's an anion. Okay, so hopefully this helps you with answering question 3. So thank you very much for watching, and I'll see you in the next lesson. Bye.